I am Tammy Beilke. I am a chemistry teacher at Metro Early College High School. In a previous mini-task, the students had taken their list of 10 dyes and narrowed it down to 3, and they did a lot of research to find out 3 main features of that dye: the time, the technical, and the money, to make a decision on what dyes would be the best choices. In this mini-task, the students are actually going to do the extraction of the dye.
A few days ago we watched a video of how to extract chlorophyll from spinach, and today, after writing down the procedure, we are extracting chlorophyll from our spinach.
During the extraction process, students were using a variety of dyes. Some used raspberries, some used a root that they described as spicy dirt because of the smell of it. One group had some tea that smelled really amazing. So they were using all kinds of different extraction procedures. No group was using the same methods.
We're using these seeds to get juice out of them so we can make a dye for our dye-sensitized solar cell.
They're experimenting, they're doing the extraction, seeing how hard is this extraction, how concentrated can I actually make this dye. And they're also looking at the actual wavelengths of light that the dyes absorbed to see if they are using a dye that's the most effective for this purpose.
We try to use natural dyes because we figured that natural plants are absorbing sunlight to survive, so they would work best as a dye form.
After the students extracted the dyes, they would bring them up to use the SpectraVis Plus and measure what wavelengths were being absorbed.
We figure if it absorbs the most wavelengths, then it'll make the most energy from the dye. But right now we think that pokeweed will because it's darkest, and black absorbs most sunlight, so we'll see.
So we would dilute the dye for purposes of testing the wavelength absorption and look at specifically the wavelengths and what the broadness of the peaks as opposed to the height of the peaks. So we want to absorb more wavelengths, and we're not so concerned about the height of the peak. So I've taken the data from one group, their 3 dyes, and overlaid it into one single Excel plot. Turmeric gave this one, so it's only absorbing in the purple region, but the beets and the wine were absorbing more into the blue and the green. So I believe the group ended up choosing the non-alcoholic wine because it absorbs the wider range of wavelengths of light. Some things I noticed in the students being successful is they were starting to think about, how could I combine my dyes? Instead of using this one dye, how can I combine the 3 to get the best features of all 3 dyes and not just the one? There were a lot of skills the students had to develop during this mini-task, but one of the most important was the procedure following. Some might have had to modify it as they worked and found that something didn't work exactly as they thought it would, and that was another skill to learn. This whole process has allowed me to really solidify what are the scaffolding items that I need to use in the class, and what kind of planning do I need to do ahead of time to make sure that things I'm teaching the students are effective and that students are learning the skills that I'm hoping them to learn so that they can make the best product in the end.